Imagine being able to harness the power of the sun here on Earth. What could that mean for our energy future? It might sound like something out of a science fiction novel, but the fact is, the sun is a natural nuclear reactor, and it's been performing this remarkable feat for over 4.5 billion years. The sun's radiant energy, which lights up our days and nurtures life on our planet, is the result of a process known as nuclear fusion. So, what exactly is nuclear fusion? Simply put, nuclear fusion is the process by which two light atoms, typically hydrogen, combine or fuse together under extreme heat and pressure to create a heavier atom, helium. This fusion process releases an incredible amount of energy, much more than what we get from the nuclear fission currently used in our nuclear power plants. The power of the sun is essentially a giant fusion reactor in the sky, continuously converting hydrogen into helium. Every second, the sun fuses about 600 million tons of hydrogen into helium, releasing a quantity of energy that's simply mind-boggling. To give you a sense of scale, the total energy produced by the sun in a single second is more than humanity has used in its entire history. Now, imagine if we could replicate this process here on Earth. The potential is staggering. Nuclear fusion could provide us with a virtually unlimited source of energy. It's clean, as the fusion process produces no harmful byproducts or greenhouse gases. It's safe, as there's no risk of a meltdown or a runaway reaction like in nuclear fission. And it's abundant, as the raw materials, hydrogen and helium, are plentiful in both seawater and the Earth's crust. So the power of the sun comes from nuclear fusion, but can we replicate this process here on Earth? As we explore this question further, we'll delve into the challenges and the future of nuclear fusion. This could be our ticket to a sustainable, clean energy future, the key to unlocking the sun's secret. Creating a mini-sun on Earth might sound like science fiction, but scientists have been trying to achieve just this for decades. So, why is it so challenging? Allow me to explain. First off, we need to achieve incredibly high temperatures, even hotter than the heart of the sun. Imagine turning your oven up as high as it goes, then multiply that heat by a factor of millions. That's the kind of heat we're talking about. We're aiming for a scorching 100 million degrees Celsius. That's approximately 6 times hotter than the sun's core. Quite the challenge, isn't it? But that's just the start. Once we've achieved these mind-boggling temperatures, we then need to contain the fusion reaction. Picture trying to hold a piece of the sun in your hands. It would slip right through your fingers, wouldn't it? That's essentially what we're dealing with here. Except instead of human hands, we're using magnetic fields to contain this superheated plasma. These magnetic containers, or tokamaks as they are scientifically known, are extraordinarily complex and require an enormous amount of energy to maintain. Lastly, let's talk about net energy gain. This is the holy grail of nuclear fusion. It's like baking a cake. You wouldn't want to spend more energy baking it than you get from eating it, right? In the same way, for fusion to be viable, we need to get more energy out of the reaction than we put in. That's a tricky balance to find, especially considering the colossal amounts of energy required to initiate and sustain the reaction. As you can see, nuclear fusion is no easy task. But what if we succeed? Despite the challenges, the promise of nuclear fusion has led to significant investment and breakthroughs in the field. The brightest minds across the globe have been tirelessly working to crack the code of nuclear fusion, and their efforts have not been in vain. One of the most promising advancements is the development of tokamak reactors. These donut-shaped machines are designed to harness the power of nuclear fusion in a controlled environment. By producing strong magnetic fields, they confine and control the fusion reactions, bringing us a step closer to replicating the sun's power on Earth. The International Thermonuclear Experimental Reactor, or ITER, is one of the most ambitious tokamak projects to date, a testament to the global commitment to this energy frontier. Laser fusion experiments, another exciting development, use high-powered lasers to compress and heat fusion fuel to the point where nuclear fusion occurs. The National Ignition Facility in the United States is at the forefront of these experiments, demonstrating the potential of laser fusion as a viable path to practical energy production. But why all this fuss about nuclear fusion? Well, it's simple. The benefits are simply too enormous to ignore. Nuclear fusion is incredibly sustainable. It uses hydrogen isotopes, which are abundant in seawater, as fuel. This means we have a virtually limitless supply of energy at our disposal. Moreover, unlike its counterpart nuclear fission, fusion doesn't produce long-lived radioactive waste. It's a clean, safe, and virtually inexhaustible source of power. Imagine a world where energy scarcity is a thing of the past, where our power doesn't pollute the environment or contribute to global warming. That's the world that nuclear fusion could create. So while the road to nuclear fusion is steep, the view from the top could change the world as we know it. Harnessing the power of the sun here on Earth is a daunting challenge, but one that could redefine our energy landscape. Throughout this exploration, we've delved into the secret workings of the sun and the complex yet tantalizing prospect of nuclear fusion. The obstacles are great indeed. Containing a miniature sun, mastering the art of plasma control, and developing materials resilient enough to withstand intense conditions are not feats to be taken lightly. But just as the challenges are immense, so too is the potential payoff. A clean, virtually limitless source of power could be at our fingertips, shifting the very paradigm of energy production. So, as we continue to probe the mysteries of nuclear fusion, let's keep our minds open to the endless possibilities that science and technology present. Let's stay informed, stay curious, and most importantly, keep pushing the boundaries of what's possible. The power of the sun might seem out of reach, but remember, the future of energy is as bright as we dare to imagine.